Hello, and welcome to this video presentation. My name is Paul Brett. I am a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is ITX Audit logging in detail. Feel free to reach out to me on popular social media channels at Paul Brett IBM. In this educational video, we're going to go through the ITX audit. We'll start with activation and go through the location and name settings. We'll discuss briefly the platform tag and how that changes through the different execution environments. We'll then discuss the execution summary, source report and target report sections. Finally, we'll activate additional options such as burst audit and settings audit. And for burst audit, I'll describe briefly the data auditing capabilities. We're starting the demonstration, as I often do, in the ITX Design Studio. As you can see, I've rearranged the Eclipse Designer so that the mapping portion is taking up a very small space down in the bottom left here, and I'm concentrating mostly on the audit log, which is going to be appearing in this main window. My map is simple. It has 2 input cards and 1 output card. Auditing is currently turned off. If I run my map, you will note that the log is not written to. If we have a look in my project directory, you will notice that I have only the one log file, test1.log, currently 0 bytes. Okay, so let's go through activating. On the map, if we bring the map settings up, I use the keyboard, Ctrl-G, but you can also go through the map menu and go into map and then into map settings. Under the map audit section, you will see it's currently switched off. The audit location is currently file map default. These should be the defaults when the product is first installed. I'm going to switch map audit to on, and I'm going to change the file name from default to unique. Now if I save, build and run my map, you will note that test1.log is still not written to, but in the directory you will note that I have an additional audit log starting with the letters MER, then the map name, then a string of numbers. This indicates a unique string that is defined each time the map is run so that the audit logs do not overwrite each other. You will note that part of the audit log includes the host name of my machine. Back to the map settings now, and if I go into map audit and change the location to default, it's going to write to test1.log and we can start to see the changes on the screen. So save, build and run. The map's completed successfully and the audit log appears in the file test1.log. Okay, so various sections of the map audit. Obviously it's very XML-like, but it's not strictly XML. We have a map audit tag here with the opposing closing tag at the end. Gives you useful information such as when the map was run. Moving on to the platform tag. Now this is quite important. It tells you what execution engine was used to run the map. And although this says Platform API for Windows, this little space here at the beginning actually tells me that this was the Eclipse Design Studio based execution. If I was to run the map from command server, you will note that the audit log changes and tells you it's command server for Windows. If I was to run the map using Java, you will note that the audit log changes to tell you it's Platform API for Windows, which is basically the Java API here in this case. You'll note that there is no space here this time, which indicates it is genuinely a Platform API execution. Whereas I'll remind you again, when we run from Design Studio, we get that little space in there just to indicate that this, although it uses the Platform API to run the map, this little space here indicates it's the Design Studio that has actually run this map. Moving on then, the version information gives you the first 3 major digits of the version. Now this information isn't as useful as a DTX ver report when support asks you for one, because the 4th digit is sometimes quite important. We can sometimes work out the 4th digit from the build number. 37 here tells me that I've got the base release of 10.1.2, and that's the only release of 10.1.2 GA available at the moment. So it's obvious that this is 10.1.2.0. If I create a file called trigger.txt, then the launcher has been set to pick up that file and execute the map as a trigger for input card 2. And if we look at the platform tags now, you will note it says launcher for Windows. So there's several of the execution environments and the different changes it makes to the platform tag. Let's move on to the meat of the audit log now. We have various sections: execution summary, source reports, target report, and then some other settings at the end. So the execution summary, very useful. First of all, it tells us the map was valid. The mapping return was 0. It tells us how long it took to run and how many bursts had to be restarted because of invalid inputs. In this particular case, this map ran in 0.0024 seconds. In the message, we have any error messages that the map would have produced, such as source not available or input type contains errors. And finally, the command line is a summary of the command line used. Now, there are no overrides, so this isn't particularly useful. It just tells us the name of the map. However, were there to be an override, let's go back to our command server example and send in an alternative string as an echo to input card 2. The map is completed successfully, and the audit log tells us the override that was used during the execution. Input echo 2, size of 5, and then there was some data sent in. The data isn't shown on the command line because that could obviously be very long indeed, but there's just this placeholder here to let you know that some data was sent in. Moving on to the source report sections. For this particular map, we have 2 of them, telling you the card number, telling you the adapter being used, how many bytes were read, and the adapter return code, 0 meaning success. We have a message that echoes pretty much the same thing, data read successfully. We have settings. Now this could vary for different adapters. For file, it tells you the location of the file. For MQ, it would tell you the MQ connection string and potentially the message ID if it was being run under the launcher. Timestamp can be quite useful. This is not telling me when the map ran, but instead when this particular input file was created, or rather the timestamp of this input file. I'm not sure if it's the last updated or the created date, but still useful information. Card 2, we have an adapter that's echo. We're echoing in 5 bytes. The timestamp isn't as useful. All it's doing is telling you the execution time of when it got to that card. I suppose it can be useful for if you're doing performance testing. Moving on to the target sections, we have target card 1. We're using the adapter file. How many bytes written? 1410, and it was successful. The message echoes that, data written successfully. It tells you the name of the output file, and once again the timestamp is telling you the point that it wrote the file out, so that's when this card finished. Potentially useful. It doesn't have microseconds, so perhaps not particularly useful in performance testing where there are very small differences between the output cards, but still useful nonetheless. And moving on to the last pieces, we've got the work area, which is set to memory, and a summary of the workspace used for each of the input cards. So that's the basics out of the way. Let's move on to activating some other sections. If I bring up the map settings again, we have map audit, which is currently switched on, burst audit, which is currently set to never for data and never for execution, the summary audit, which is set to always, which is what we've been looking at so far, and the settings audit, which is set again to never for both data and map. Now I'm going to turn on the burst audit to always for both of those sections. I'm going to save, build and run and show you the differences that appear. Whereas before the execution summary was directly after platform, now execution summary is down here, platform is here, and in between we have the burst section, which includes the execution log, input and output statuses for the card, and potentially, if you have data auditing turned on, data audit settings would appear here. Now let's do some data auditing so that we can see actually something come through there. I'm going to bring up the data auditing window by going into Map and switching to Data Audit Settings. I want to audit the name field. So over here in my input card 1, I'm going to drag name into the audit. I'm going to track every occurrence, and I want the details for every occurrence. I'm not going to turn on the item data just yet. Save, build, run. Now in the data log section, every time an occurrence of a name field was found, you have a data log for that object. Tells you where it is, index 1, level 2, tells you the size of the data, but not the data itself, just the name of the field. Okay, let's turn on that last option, item data. Turn on audit the item data for every occurrence. Save, build, run. Now the block includes not only every time it's found, but also the data that's found. Steve, Jane, David, Marcus. Potentially useful. Potentially this audit could be massive if your input is massive. This is where you would maybe narrow down when you want to have the data audited. Instead of occurrence, you would maybe want to have it if there is a warning or an error. If I change this now to warning, save, build and run, you will note that all of the objects are still audited, but none of the data has appeared because every single item is completely valid. Okay, let's go back to our map settings again, and temporarily let's turn off the burst audit settings because they get in the way, and let's turn on the settings audit instead. Always for data and always for map. So let's save, build, move data settings window out of the way and run. You will note now that the platform and execution summary are both together again. The burst data is not in the middle, there's no data auditing going on, it's just turned off at the moment. But if we come down to below the original area where the execution summary finished, and then it was showing the map audit end at the end, you can see there's a big chunk in the middle now. We have a map settings section. Okay, this is fairly self-explanatory. It's all the map settings written out in full in the map audit log. For example, it's telling us the map audit is switched on. It's telling us where the audit can be found. It's telling us the name of the audit log. Well, we should know this by now because that's the file we're reading. But anyway, useful information, especially if it's a unique audit name. And that unique name also matches the name that's used for writing out the trace information if you later need to rely on that. A quick summary of the workspace settings being used. Then all the other map settings, custom time zone, sliding sentry, custom validation, etc. Moving beyond the map settings, we get to data settings. These are a summary of the card mode, whether the work area was reused, backup, whether that's switched on or off, and the backup location would be listed here as well if it was switched on. The source adapter and the settings for that adapter, such as rollback and whether to ignore warnings. All of the data settings for all of the input cards here, and all of the output card here. And that's basically the data audit settings. In summary then, the audit log can be used to check settings, it can be used to check data, but mostly we use it for the execution summary, which tells us the useful information such as elapsed time and the success status of the map, and the individual input and output card statuses. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button. Consider subscribing to my YouTube channel as I produce content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.